Hi and welcome to this video. This is one of a series of videos that I'm producing which will go through how to answer some of the common exam questions that come up for Level 2 Organic. And one of the first and most common questions that comes up every single year is about cis-trans isomers and isomerism. So let's have a look at that first. The most common type of question you get is going to look something like this. It will ask you to either possibly to identify which molecule may exist as cis-trans isomers. It may already tell you that. It's going to ask you to draw both the cis and trans isomers for a given molecule. It's going to ask you to justify or explain or elaborate, could use any one of those words, exactly why you have drawn that cis-trans, those isomers as they are, why you selected that molecule, and possibly why no other molecule can exist as a cis-trans isomer. They vary slightly, but not a lot. They tend to have that same general pattern. So here's a classic example. Before I get to an example, let's look at the sorts of things you need to put in your answer. So if you've been asked to choose which isomer, which compound, then obviously you need to choose the one with a double bond and two different groups on each carbon. You need to draw them both clearly and accurately. And then you should explain the requirements for a molecule to form cis-trans isomers, in other words, that it has a double bond which doesn't allow rotation in the molecule, and there must be two different groups on each carbon in the double bond. Link the features of your molecule back to that definition. Explain how you've decided which molecule is cis and which molecule is trans, and if you've been asked why some other molecule isn't existing as cis-trans isomers, then explain why. So here's an example. This was the question in the 2019 exam. Now, read the question carefully. So this refers to the molecules there, A and B. So the first part says to draw and name the two geometric isomers of compound A. And the second part says explain why compound A exists as cis-trans isomers while compound B doesn't. Okay, so there's two parts to this. Why does compound A exist as cis-trans isomers? Why doesn't compound B exist as cis-trans isomers? Although it's not explicitly stated in the question, when you've drawn your cis and trans isomers, I would also explain why you chose one to be cis and the other one to be trans. Sometimes it's just good to cover your butt like that. So here's the sort of answer that I would look at. First off, we've got our molecules, okay? Cis-butene and trans-butene. Now just drawing and naming those will get you at least an achieved point, if not a merit point, as long as you've named the correct one as cis and the other one as trans. And the sorts of answer. Okay, now this one I haven't actually got that fun little bit of explaining why compound B doesn't form cis-trans isomers, but I would do that verbally, so just bear with me. So first off, the definition. To form cis-trans isomers, a molecule must contain a double bond which does not rotate and have two different atoms or groups of atoms attached to each carbon in the double bond. Okay, so there's the requirements, and that's the first part that you need to have. Now, linking the molecule back to those requirements, butene has a double bond between carbon 2 and carbon 3, and each carbon has a hydrogen and a CH3 or methyl group attached. So it can exist as cis-trans isomers. Now what should also be in here, of course, is that compound B, which was butane, does not have a double bond. Therefore the molecule can rotate and it does not exist as cis-trans isomers. The cis isomer has both hydrogens on the same side of the double bond, while the trans isomer has the hydrogens on opposite sides of the double bond. Now this is the sort of question that you can find in every year's exam papers. It's just always there, 2019, 2018, 2017, 2016, 2015, all the way back. You will always find a question that falls into this general category. It's usually an excellence question, though very occasionally it's only a merit question, and almost inevitably they're looking for an answer that falls within this general range. Definition, link the molecule to the definition, and then fill in any other little bits and pieces that are going on. When you do it like that, you'll get good marks every time. I will see you with the next one of these videos once it is done. Take care.